I'm Chris Harrop. I'm with the University of Colorado at Boulder, but I'm embedded at the Global Systems Laboratory in NOAA. And I'm just going to talk about a few enhancements, maybe not ones that blow your mind, but hopefully you'll find useful for integrating Parsl and Globus Compute together. So the goal is really to reduce the cognitive load for the person who's developing a workflow. We don't want the person worrying about where resources are located when they're designing the workflow. We want them focusing on what they're trying to run and what they're trying to do. And so we want to, the goal of these enhancements is to allow workflows to intermix Globus and Parsl compute tasks without the user having to think about it.
We're told this audio is gone.
No audio, Robert, you can't hear us?
I can hear you just fine. Well, I could hear Chris talking just fine.
Okay, so it might be a Robert. Okay.
Okay. All right. Okay. So basically, this involves three separate sort of sub goals. Number one, workflows don't know if the resources are local or remote, and all of the details about the resources is just completely confined to a configuration file. And workflows can create tasks and choose where those tasks run at runtime. So we're not constrained by the executor that was defined when the class was defined. And then we'd also like to have templatable endpoints for Globus Compute. These are multi-user endpoints, but we want them managed in user space. And we want the management of the lifecycle of these endpoints to behave the same way that you manage the user endpoints. All right. Okay, so to accomplish the first goal, we just have everything living in a configuration file. It's just a simple YAML file where we have some resources with a certain name, and all of their attributes are just defined in there. And then based on those attributes, we feed that configuration through some factories for creating the providers and the various executors for each of those resources. And then at the end, we construct a Parsl config that we can then use to load Parsl. And what this allows us to do is we have our configuration with the named resources, and then in our workflow, we just load the configuration, and then we can have a set of tasks that are all wrapped up inside of a Python class, and we can call those tasks and give an executor just by name at runtime. We can choose the name at runtime, where they're deployed, where they get executed. So what this allows us to do kind of leads into the next topic, which is the dynamic aspect of running the tasks. So we choose where these things go at runtime based on their name, and the way that this works is we have to back up just a little bit. Normally, when you have like a bash app, for example, and you want to use this for a method in a class, there are some problems with this. The first problem is that the executor is defined when the class is defined at load time, and the use of self is not allowed, because when the task gets executed, it doesn't know what self is. So that won't work. So we can't do that. So to get around this, we created a new decorator that wraps the Parsl decorator. And the way that this works is that it actually creates the Python apps at runtime. So it actually it dynamically creates the app and then executes it all in one call. And this allows you to make use of self, because self is evaluated when you create the Parsl app. And it allows you to choose where it gets executed, because now you've specified the executor at runtime when it's created. And the way that this decorator works, this is just sort of a little excerpt. It's just your classic decorator pattern. We're just wrapping the original decorator with a new thing that adds an executor argument to it. All right. So that takes care of dynamic creation of tasks and deploying them to resources that we want and choosing the resources at runtime. And we have encapsulated all of the details about all of the resources, hidden the complexities of local or remote, whether it's an endpoint, whether it's a local resource, all in the configuration file. And now what about the endpoints? So multi-user endpoints behaves a little bit differently. When you start them up, the behavior is different. And when you shut them down, the behavior is a little bit different. The commands, for endpoint start, stop, and so on are not quite the same as with a user endpoint. So to simplify things, we decided to wrap all of that in our own CLI. And so Chiltepin is the application that I'm working with. And the first thing we have is a login command. And what this does is it goes and logs you into both transfer clients and compute clients all in the same step. So you don't have to worry about that. And it gets all of that information for you. Then for configuring an endpoint, it just looks exactly the same as it usually does, but the way that we provide a better user experience is we run the Globus compute endpoint configure with the multi-user argument under the hood, and then we do a whole bunch of other stuff, like we get rid of the identity mapping file, we install a very complicated custom template for all the Jinja stuff so that when the user endpoints get created with the stuff that was from the configuration file, it actually deploys the correct user endpoint at runtime. And we adds a whole bunch of stuff to make sure that the user environments work properly. Because one of the things that you discover is sometimes when your user endpoint starts up from the multi-user endpoint, it can't find Slurm commands. So we automatically take care of all of that stuff. And then, yeah, never mind. Then when we start the endpoint, we add a little bit of magic sauce by just creating a daemon.pid file. And what this does, for some reason, the multi-user endpoints don't do that. What this does is it allows the standard Globus compute endpoint list and stop commands to work the way that they normally do. And then we just wait for it to start up. And then stop works just as, because we created that PID file, stop works the way that you expect. And so we've got sort of some convenience wrappers around endpoints so that they give the user a similar interface for multi-user endpoints that you would expect from a user endpoint. It's a little bit nicer. And we've got configuration, all the brains of the whole thing of local versus remote, Globus compute versus Parsl. It's all in the configuration file. And we've got custom decorators to allow us to do things, create tasks dynamically and deploy them choose where we want to run things on the fly.